My name is Brandon Araki. I work with Daniela Rus at the Distributed Robotics Lab in CSAIL, and our work is on making robots more intelligent so that they can help people in their everyday lives. The name of my project is Learning and Planning with Logic. The idea is to enable robots to learn logical rules by observing demonstrations, and then effectively plan with those rules. For example, a robot chef should be able to observe a human chef preparing a dish, learn the recipe that the chef was following, and then cook the dish itself. I'm trying to address a few big problems that machine learning is facing today. The first problem is that neural nets are not interpretable. It's very difficult for machine learning engineers to figure out what a neural net has learned by looking at it because their structure is so complicated. We make deep learning more interpretable by explicitly learning rules, so it's very easy to see what the robot has learned. The second problem is that it's hard to modify a neural net once it has learned something. For example, imagine that a self-driving car has learned to occasionally run red lights. If you're using a neural net to represent this rule, there's no way to change it. We get around this by integrating the rules that we learn directly into planning, so that if you tweak the rules, the output of the algorithm will change accordingly. If you notice that the car has learned rules that allow it to occasionally run red lights, you can change the rules to prevent it from ever running a red light. The third problem is that most deep learning techniques today require a huge amount of data to learn. We use powerful new tools from probabilistic programming to enable robots to learn the rules of a task from just a handful of demonstrations. We should be able to give a robot an instruction manual for a game, or a recipe, or a book of driving laws, and it should be able to understand and obey those rules. Today, the most powerful and promising learning techniques, using tools such as neural networks, struggle to learn rules. We have to figure out how to reconcile deep learning with rules if we want robots to be able to perform complex tasks.